Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Today we're going to be continuing the series on how to solve trigonometric functions using product rule, and this is episode 11 of the series, hence the 11th question. If this is the first time that you're here on my channel, this is a series that I've been doing for the past couple of days. It involves trigonometric functions and how to apply them with product rule, chain rule, quotient rule, and yeah, that's basically it. So for this particular video, we have f of x equals tan x multiplied by secant x, and we're supposed to find the derivative of this function. Now, the first thing you need to know is, based on observation from the title, the thumbnail, and also the first few things I've said in the video, you would know we're going to use the product rule because we have two sub-functions, f of x here, which is going to be tan x, when we compare it to the general formula. So f of x here is tan x, right? And then g of x is equals to secant x. And tan x and secant x are multiplied by each other. And in order for you to differentiate two or more subfunctions that are multiplied by each other, you have to do something different. And what you have to do is to apply the product rule in order for you to properly differentiate it. Now, the general formula for product rule is the derivative of the first subfunction that you're given multiplied by the second subfunction plus the derivative the derivative of the second subfunction multiplied by the first subfunction. So therefore, we're going to find the derivative of tan x multiplied by secant x. Right, so the derivative of f of x here, we know f of x to be tan x. So the derivative of tan x multiplied by the second subfunction secant x plus derivative of the second subfunction, which in this case is secant x. So the derivative of secant x multiplied by the first subfunction, which is tan x. Right? When you have all of this information, next thing you do is, what is the derivative of tan x? Now, if this is the first time on my channel, then you probably do not know this. In each one of my videos that involves trigonometric function, like for trigonometric function for quotient rule, trigonometric function for chain rule, right? So the trig notes has a list of formulas or a list of information about trig to help you whenever you're solving questions that involve trig. So on the left side of this trig note, we have what is called the trig expression. And trig expression is just how one trig function relates to another trig function. So for example, we have sin x equals 1 over cosecant x, as well as cosecant x equals 1 over sin x. In this trig expression information with all the stuff on the left side that is true, you can see that sin x relates to cosecant x in terms of reciprocals, right? The same way cosine x relates to secant x, right? Whenever you're thinking of them as reciprocals, because cosine x equals 1 over secant x, the same way secant x equals 1 over cosine x. And then of course we have tan x and cotangent x and how they relate to one another, as well as how they relate to sin x and cosine x. Now on the right side of the page, we have trig identities. Trig identities just basically involve whenever trigonometric functions have power of 2. So the power of 2, like sine square x plus cosine square x equals 1, and how they relate to one another. They usually help, obviously, with like substituting and helping us to be able to get the answer that we're looking for, or they help us in some calculation of mathematical expression that involves trig, just like everything else on this page. On the right side at the bottom, where everything is written in the left, as well as on the left side on the bottom, what we have is trig derivatives. So this is what we actually need right now that I came to this page. We're dealing with trig derivatives, and it just involves derivatives of trig. And please, if this is the first time that you're watching my videos, make sure you pause this video right now and copy all of this information down. Okay, so the next thing you have is to ask for the derivative of tan x, right? Well, the derivative of tan x, you can see the derivative of tan x is equals secant squared x. So I'm going to put equals to secant squared x multiplied by secant squared x, which is just this information down here. It just drops down, plus the derivative of secant x. What is the derivative of secant x? We go back to the trig notes, we see secant x, the derivative of secant x is the same thing as secant x tan x. So we write plus secant x tan x. And then we have our gorgeous tan just chilling right here. We're just going to put it down here and just say multiplied by tan x. So at the end of the year, our answer becomes secant, right? We can bring out secant x just to observe how things are. And we can see that we end up with secant squared of x plus tan squared of x. So this bringing it out is just a way for us to simplify our work, and what we end up with is secant squared x plus tan squared x. Now this is the answer to the product rule, and this is perfectly correct. If you put this in your answer, whether you multiply through or you don't multiply through, or you don't multiply through by simplifying this way, the answer is correct. Now I just want to work more on what we have, and I want to work because when we're handling trig, it is best for you to break things down and see if there's a way for you to make your work more compact and neater. And basically what I'm trying to say is we're trying to simplify. We're going to try and simplify this answer further to make sure our answer is more clean and more clear, right? Just like we do in math, right? If you have 50 over 100, would you rather have it 50 over 100 or would you have it to be 1 over 2? I believe majority of people would rather take the 1 over 2. That's what we're trying to do here. We're trying to simplify. We're trying to make our work much neater. And that's it. So we have our question to be secant x, not our question. The information from the previous page to be secant x multiplied by secant squared of x plus tan squared of x. Now to simplify, the first thing we can do is to go back to our trig notes and look at our trig notes to see if there's any way we can break down the information and whatever we can do to simplify. Look at our trig notes, we see that this doesn't really help. Nothing in the trig expression helps, especially because our questions have higher power of 2. So let's look at the trig identities. When we look at the trig identities, we see that tan squared x plus 1 is equal to secant square x, right? So let's see that if we put tan square x plus 1, let's see what is going to happen, right? So remember that tan square x, so I want to rewrite it here so you guys would see what we're doing more clearly. Plus 1 equals secant squared of x, right? So if we're trying to substitute and have everything in secant, what we can do is to substitute tan squared x in terms of secant, right? So what we can do here is to say tan squared of x equals secant squared of x minus 1. So what you end up with is secant x, right, multiplied by secant squared x plus secant squared x minus 1, which is basically what we had here. And then let's see what happens. So therefore we end up with secant x plus secant squared x plus secant squared x plus secant squared x. In this case is what? It's 2 secant squared x. And then we just have 1 chilling over there. So we're just going to say minus 1. So when we multiply through, we have that to be 2 secant cube of x minus secant of x. Okay? So this is our answer. The derivative of tan x multiplied by secant x equals this answer. So now remember what I said. This answer right here is correct. Secant x multiplied by secant square x plus tan square of x, right? And then this one too is also correct. But I would advise you, just out of making your work neater and more compact, since we're dealing with trig, this 2 secant cube x minus secant x is actually a lot simpler. That's just the truth. It's a lot simpler. 2 secant cube x minus secant x is a lot simpler. So yeah, that's basically how you solve and how you derive tan x multiplied by secant x. One thing you should know is, like, whenever you watch my videos, like you guys that have watched the first 10 episodes of the series, or I've already peeped through like episode 12, 13, 14 or whatever, one thing you need to know is I always talk about shortcut method, right? I will teach you stuff, then I'll teach you the shortcut method, which involves simplifying the function and then deriving the simplified version of the question, right? For example, if you had like cotangent x multiplied by tan x and you were asked to find the derivative of this, I taught you guys how that you can say cotangent x is the same thing as like multiplied by 1 over tan x, right? Then you can simplify by cancelling these two out, and voila, you end up having 1, and then instead of differentiating cotangent x multiplied by tan x, you differentiate 1, and then you get the answer to be 0. The truth is, when you now do the differentiation of this one by itself, what you're actually going to get is that the answer would be 0. The differentiated answer of that is also going to be 0. So that's a shortcut method, and I taught you guys that for a couple of problems. Like the first 10 episodes, majority of the problems had shortcuts to it. Unfortunately, this one doesn't have any shortcut. The shortcut is actually more what we would call the shortcut, which is trying to simplify the function, and then finding the derivative of the simplified version does not happen here. Instead, when we try to simplify, we're just going to make our work we're instead going to make our work more complicated. So if we have tan x, right, multiplied by secant x, it's like saying sin x over cosine x multiplied by 1 over cosine of x, because tan x is the same thing as sine over cosine, and secant is the same thing as 1 over cosine. We end up having sin x, right, over cosine squared of x. First of all, we're not going to be able to use the product rule on this one. We're just going to have to use the quotient rule, and this time around we have a power. So it's not really going to make our work easier. Instead, what we're going to be stuck doing is that we're going to see what the equivalent of cosine square x is using other trig expression information or trig information, and then try to find the derivative. At the end of the day, it's going to be much more complicated. So I'll advise you to stick to the product rule, because the product rule is a lot easier, and the shortcut method that I used for the previous examples does not quite work for this one. So I just wanted to make sure you guys knew that. So if you like this video, make sure you subscribe and make sure you watch the other episode. If this is your first video on my channel, make sure you look at the series and learn more from the other videos, inshallah. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.